It was a blessed second when the Andromeda cloud, for the time being, turned into the Andromeda cosmic system. The James Webb Telescope has recognized 6 worlds that exist 500 million years after the huge explosion. This is unimaginable when you check the evening out on the town sky. A pinpoint of light, when extended, gives you one of these photos from the Webb Space Telescope. It was a blessed second as the Andromeda cloud changed into the Andromeda world. 4 years ago, our comprehension of the Andromeda world was restricted to based perceptions. Anyway, with progressions in innovation and the introduction of the James Webb Space Telescope, our comprehension has developed incomprehensibly. Now, things are going to change as the James Webb Space Telescope has distinguished disturbing signs coming from the Andromeda universe. These signs have sent shock waves through the academic community, leaving stargazers both motivated and inquisitive. Yet, what precisely do these signs mean, and why are they creating such a ruckus among space experts? Join us as only 2 minutes prior, the James Webb Telescope shut down in the wake of getting disturbing signs from the Andromeda cosmic system. Before we could see a long way past our eyes into the universe, cosmologists trusted the Milky Way for being the entire universe. This absence of knowledge was basically due to restricted innovation for seeing different cosmic systems and individual stars. Anyway, everything changed when we found the Andromeda world. It filled in as our most memorable clue that the universe extends a long way past the Milky Way. In the 17th century, Galileo Galilei's spearheading work with telescopes uncovered the Milky Way's obvious nature. He saw that the Milky Way had various stars, testing the winning thought of its particular significance. Everything changed in the 1920s when Edwin Hubble found far-off objects past the Milky Way utilizing the Hubble telescope. Edwin took note that these heavenly articles moving through the universe were worlds not quite the same as the Milky Way. One of the systems was the Andromeda world, or M31. While this was when we first saw the Andromeda world through a telescope, Persian cosmologist Abd al-Rahman al-Sufi first noted it around the 10th century. On account of mechanical headways in the 20th century, space experts could see and figure out the real essence and embodiment of Andromeda. It is a shapeless cloud comprising a tremendous world of stars like our Milky Way. Our inestimable neighbor is around 2.5 million light-years from the Milky Way. Since its disclosure, the way we concentrate on Andromeda has significantly advanced. We have moved from ground-based perceptions through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Each progression in innovation has taken us higher than ever, assisting us with understanding the mysteries of the Andromeda universe. We now have more data and knowledge into its composition and structure, making Andromeda a benchmark for contemplating the development and evolution of universes. This has revealed more insight into the more extensive working standards of the universe. Researchers trust that to have a superior comprehension of our universe and the Milky Way, we should concentrate on the relationship among Andromeda and the Milky Way. This is particularly evident given that both systems will undoubtedly crash in around 4 billion years. While studies and examinations have advanced, the James Webb Telescope has recently gotten a disturbing sign from Andromeda. This disturbing sign perplexes researchers overall, inciting inquiries regarding its careful beginning and potential ramifications. The James Webb Telescope's high-level sensors have distinguished uncommon movement just inside Andromeda's center. The sign sent back to researchers shows results that contrast altogether from past perceptions, captivating researchers overall. The signal demonstrates significant cycles going on inside the world, possibly connected to its really monstrous black hole or beforehand unseen events. Strikingly, one of the most recent findings demonstrates that Andromeda's mass might be a lot greater than that of the Milky Way, reshaping how we might interpret both cosmic systems. The James Webb Telescope has additionally provided detailed pictures and spectra of Andromeda, revealing the development of new stars and their compound structures. This new information is significant for understanding cosmic evolution and potential circumstances for life. Moreover, the information from the telescope proposes expanded movement in Andromeda's dynamic cosmic core. This has eventually influenced its encompassing climate and is anticipated to shape its future construction. Besides, by investigating the gravitational impacts on stars inside Andromeda, specialists acquire insights into the dispersion of puzzling dark matter all through the cosmic system. Hopefully, This assists our comprehension of its impact on the elements at play in the universe. Figuring out dark matter and its effect on the universe is one of stargazing's most prominent riddles. Late forward leaps by the James Webb Telescope have inspired different investigations overall, as researchers investigate the insider facts of Andromeda, with more data becoming known. We now find out about the system's past and future. So, what have we found out about the Andromeda world through different investigations? Andromeda has shown noteworthy qualities that recognize it from different worlds spread across the universe. Its sheer size commands consideration, with late evaluations recommending a breadth traversing around 220,000 light-years. This figure makes it one of the biggest cosmic systems in the neighborhood bunch, much greater than the Milky Way. This huge scope adds to its mass, comprising an expected trillion stars, outperforming our cosmic system in heavenly count. Research additionally views the system's structure as captivating. Not at all like a normal winding system, Andromeda has a swelling focus and a thick core encased inside rings of residue and gas. This is undoubtedly a rich ground for continuous star development. Such highlights show a dynamic universe made by consistent processes molding its evolution. Among its many elements, one of specific interest is its core. It is described by a twofold pinnacle discharge, indicating the presence of a supermassive black hole, yet not quite the same as the Milky Way's. This offers significant experiences into the nature and activities of these gigantic matter-eating openings. The Andromeda world is likewise surrounded by a circle of heavenly garbage, comprising of stars, planetary, and globular groups traversing many huge numbers of light-years in breadth. This enormous covering tells an enthralling, itemized story of the world's interesting beginning and history. The 460 globular groups found in Andromeda likewise offer knowledge into the arrangement of stars in the beginning phases, giving a clear clarification of the development of star groups and the early turn of events of the universe. In sorting out the mysteries of Andromeda, stargazers are one bit nearer to understanding the enormous pertinence of dark matter. Anyway, one inquiry waits: how do they account for its baffling nature and the job it plays in the elements of cosmic systems? Andromeda gloats another unmistakable element: its satellite universes. Its corona structure is comprised of more than 20 more modest cosmic systems, and some of them are going through flowing depriving of their stars and gas. This cycle includes a bigger cosmic system pulling in and annihilating adjoining little cosmic systems. This demonstrates the dynamic nature of vast development and depicts how worlds develop and connect with one another over the long haul. So, what does the future hold for the Andromeda system? The shape and heading of its development entrance not just cosmologists but also those trying to comprehend the universe. The chance of its progress from a winding to a ring universe is centrally vital in Andromeda's advancement. Proof focuses to an interaction that could prompt other intriguing blends, perhaps from cosmic impacts or close associations with different universes. If Andromeda truly is moving toward this path, it implies that it has encountered numerous connections with different cosmic systems since its introduction to the world. Ultimately, Andromeda's future relies upon the inescapable crash with the Milky Way. As indicated by these models, the impact is assessed to generally happen 4 billion years from now. The consequence of such an impact is the introduction of a new world from these two Goliath heavenly substances. However damaging, the impact is a characteristic piece of cosmic advancement. Anyway, due to the huge distances between the worlds, this cosmic crash is definitely not an immediate effect. After the impact, the two cosmic systems would be profoundly rebuilt, framing new shapes and organizations. The communication of their gases and residue will work up new rounds of star creation, prompting a huge exhibition overhead as the blending objects sparkle brilliantly. Ultimately, such an inestimable occasion will result in the development of a solitary circular universe. This sort of impact isn't exceptional, as the universe has a long history of such occasions. Anyway, our direct interest makes it an occasion important to us. Also, the anticipated crash of the very huge black holes at the core of the two universes adds more secret to the heavenly show. This recommends a complex and profound nature of vast development. The consolidation is anticipated to deliver blasts for issue being inundated by the black hole, which will deliver broad radiation. This interaction offers significant information about how cosmic systems move all through their life expectancy and how black holes influence this development. Anyway, it brings up a crucial issue. What will happen to our nearby planet group after this consolidation is shaped? Not even close to an aggregate annihilation of the nearby planet group, the nearby planet group's direction and conditions could be adjusted fundamentally. This suggests conceivable circle moves or even launch from the recently arose cosmic system. To grasp this instrument, researchers can study the size of comparative occasions occurring and contextualize the possible destiny of our own universe. It is pivotal to comprehend that a crash between stars is an uncommon occasion in space because of the tremendous intergalactic distances. Anyway, the gravitational change could upset stars' stable circles, causing some stars, including our Sun, to change direction. Such a change could significantly upset the environment on Earth. Perhaps, of the most basic change people could encounter is moving further away from or nearer to the Sun. This could lead to one or the other warming or cooling impacts. A warmer environment could make ice covers liquefy and ocean levels ascend, while a colder one would prompt another ice age. On top of that, the calculation of such an arrangement could impede radiation levels coming to Earth, making much more testing conditions. The Milky Way and Andromeda cosmic systems are bound for an emotional impact, an occasion that will reshape the inestimable scene. This impact, assessed to happen in around 4 billion years, will be quite possibly of the most critical occasion in the universe's timetable. As the two worlds wind toward each other, their shared gravitational fascination will start a mind-boggling dance of vast powers. The crash isn't a direct effect but a continuous blending process. During this cycle, the cosmic centers will ultimately coalesce, prompting the development of another mixture cosmic system. In the underlying phases of the crash, communications between the cosmic designs will set off extraordinary star arrangement. The gravitational unsettling influence will pack interstellar gas and residue, lighting new star births. This starburst movement will make a dynamite show of heavenly firecrackers, with infant stars enlightening the consolidating worlds. The gas and residue mists, mixed by the crash, will shape thick locales that encourage star bunches and nebulae, adding to the visual magnificence of the occasion. As the crash advances, the elements of the cosmic systems will move emphatically. The Milky Way's twisting arms and Andromeda's comparative construction will be disturbed, causing tremendous changes in their heavenly circles. These disturbances will prompt the arrangement of new cosmic designs, for example, flowing tails and floods of stars. The end result will be a solitary, more monstrous curved world, another enormous element brought into the world from the association of the Milky Way and Andromeda. The investigation of cosmic impacts gives critical bits of knowledge into the existence pattern of worlds. Perceptions of other cosmic system consolidations in the universe offer a brief look into what could happen when the Milky Way and Andromeda crash. For example, the converging of worlds, the antennae worlds or the collaborating arrangement of NGC 438 and 439, highlights the groundbreaking impacts of such astronomical occasions. These perceptions assist us, space experts, with demonstrating the future advancement of our own cosmic system crash and comprehend the multifaceted processes included. The crash's influence on individual stars and planetary frameworks will be less disastrous than one could expect. Albeit the gravitational cooperations will change heavenly circles, the immense distances between stars imply that immediate heavenly crashes are uncommon. Anyway, the solar system's position and direction within the new cosmic system could be essentially modified. This shift could prompt changes in the world's circle and environment, possibly influencing the habitability of our planet. The blending system will additionally have significant ramifications for the very huge black holes at the focuses of the two cosmic systems. The Milky Way's black hole, Sagittarius A*, and Andromeda's black hole will ultimately converge to frame a much bigger black hole. This consolidation will be joined by the arrival of huge measures of energy as gravitational waves and radiation. The investigation of these peculiarities will offer significant bits of knowledge into the way of behaving of black holes and their job in cosmic system arrangement. Notwithstanding cosmic impacts, the progressing headways in cosmic innovation keep on upgrading how we might interpret the universe. The send-off of new space observatories and telescopes, has altered our capacity to notice far-off systems and astronomical peculiarities. Instruments like the James Webb Space Telescope, with its high-level infrared abilities, have divulged beforehand concealed insights regarding the universe. The capacity to look through grandiose residue and gas has prompted disclosures about the arrangement of worlds, the idea of dark matter, and the circumstances for life. Radio telescopes like the Very Large Array, VLA, and the Square Kilometer Array, SKA, are growing our insight into the universe's construction. These telescopes identify radio waves produced by far-off systems, pulsars, and other divine objects. By concentrating on these radio discharges, stargazers can test the properties of grandiose attractive fields, gas mists, and the conveyance of dark matter. Gravitational wave observatories, for example LIGO and Virgo, have opened a new window into the universe. These observatories distinguish swells in spacetime brought about by occasions like black hole consolidations and neutron star impacts. The investigation of gravitational waves has given experiences into the elements of reduced parallel frameworks, the idea of black holes, and the central properties of gravity. The improvement of new observational procedures and information examination strategies is likewise playing a vital job in propelling our comprehension of the universe. Machine learning and artificial intelligence are being utilized to break down immense sums of galactic information, recognize designs, and make expectations. These advancements are assisting space experts with characterizing cosmic systems, recognize exoplanets, and study the advancement of infinite designs. The investigation of exoplanets and their potential livability is another energizing frontier in cosmology. The disclosure of Earth-like planets in the habitable zones of far-off star frameworks raises the chance of finding extraterrestrial life. Missions, for example, the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite TESS, have distinguished a great many exoplanets, some of which have attributes like Earth. Future missions will keep on exploring these universes and quest for indications of life. The investigation of astronomical expansion, dark energy, and the speeding up development of the universe is giving responses to principal inquiries concerning the beginnings and destiny of the universe. The disclosure of dark energy, a secretive power driving the universe's extension, has reshaped how we might interpret cosmology. Exploration into these points expects to unwind the nature of the universe's development and its definitive predestination. In outline, the impending crash between the Milky Way and Andromeda addresses a critical second in the universe's development. The coordination of these two universes will reshape their designs, trigger Sirius star arrangement, and lead to the development of another curved world. Progressions in galactic innovation and observational strategies proceed to extend how we might interpret enormous peculiarities. The investigation of cosmic impacts, black holes, and astronomical extension gives valuable bits of knowledge into the idea of the universe and its continuous development. As we investigate these grandiose occasions, we gain a more prominent appreciation for the dynamic and ever-changing nature of the universe.